so I'm going to 1. Strike that inverted. Inverses of power functions. Warm up. Determine whether each graph represents a function. Explain your reasoning. So we're going to use what's called the vertical line test. Okay, so what the vertical line test is we draw a vertical line. If it crosses the function only once, then it's a function. Okay. So here it crosses once, twice, so not a function. Here, this one only crosses once, so it's a function. Okay. All right, let's go ahead and take a look at the next page. Getting started, reflect on it. Consider the polygon drawn on a coordinate plane. Okay. So before we start anything else, we need to go ahead and take these points and apply to a table. So A is -4, -4. B is -5, -2. C is -1, 0. D is -2, 4. E is 2, 3. F is 1, 5. And G is 5, 5. Okay. 2. Draw the reflection of the polygon across y equals x on the same coordinate plane. Now, to reflect, you switch the points. Okay? So let's go ahead and do that. So write the coordinates of the named vertex of the polygon after reflection. So we're going to reflect the points. So then this is -4, -2, 0, 4, 3, 5, 5. And this is -4, -5, -1, -2, 2, 1, 5. All right. So now we're going to go ahead and graph these points. So let's go ahead and do that now. All right, so -4 is A. -2, -5 is B. And let's connect them as we go. 0, -1 is C. 4, -2 is D. 3, 2 is E. 5, 1 is F. And 5, 5 is G. Okay. All right, go ahead and finish that up. 4. Compare the coordinates of the vertices of the original polygon with the coordinates you wrote in question 3. The x and y coordinates of all the vertices switch positions from the original polygon. Right, let's take a look at the next page. Activity 1.1, switching x and y. The graphs located at the end of this lesson show that these three power functions, L of x equals x, Q of x equals x squared, and C of x equals x cubed. Trace each graph, label the axis as shown in the original graph. Label each function to help you identify them. 2. The graphs of the linear function L of x equals x models the width of a square as an independent quantity and the height of the square as a dependent quantity. So here is the table that corresponds to L of x equals x. Transform L of x so that it shows the height as the independent quantity on the horizontal axis and the width as a dependent quantity on the vertical axis. Then sketch the resulting graph and label the axis. So we're going to switch the x and y. So then this is -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. All right, let's go ahead and graph that. So -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. All right, go ahead and complete that. All right, let's take a look at the next page. B. Describe the transformation used to transpose the independent and dependent quantities. I reflected the graph across the line y equals x, which switches the independent and dependent quantities. C. Is the resulting graph a function? The resulting graph is a function. D. Compare the graphs L of x equals x to the resulting graph. Interpret both graphs in terms of the width and height of a square. The graph of L of x equals x shows that as the width of a square increases by x units, the height also increases by x units. The resulting graph shows that as the height of a square increases by x units, the width also increases by x units. 3. The graph of the quadratic function Q of x equals x squared models the side length of a square as the independent quantity and the area of the square as a dependent quantity. Transform Q of x so that it shows that the area as the independent quantity on the horizontal axis and the side length as a dependent quantity on the vertical axis. Then sketch the resulting graph and label. Okay, so here's the table that corresponds to Q of x equals x squared. Now, we're going to reflect, so we're going to switch the x and y values. So this becomes 4, 1, 0, 1, 4. And this becomes -2, -1, 0, 1, 2. Okay. So 4, -2, 1, -1, 0, 0, 1, 1, 4, 2. All right, go ahead and finish it up. Let's take a look at the next page. B. Describe the transformation used to transpose the independent and dependent quantities. I reflected the graph across the line y equals x. C. Is the resulting graph a function? The resulting graph is not a function. Go ahead and mark that out. E. Compare the graphs of Q of x equals x squared to the transformed graph you sketched. Interpret both graphs in terms of the side lengths and the area of the square. The graph of Q of x shows that when the side length of a square is x units or negative x units, the area is x squared units. The resulting graph shows that when the area is x squared units, the lengths are negative x units and x units. Let's take a look at the next page. 4. The graphs of the cubic function c of x equals x cubed models the side length of a cube as the independent quantity and the volume of the cube as a dependent quantity. 8. Transform c of x so that it shows the volume as the independent quantity on the horizontal axis and the side length as a dependent quantity on the vertical axis. Then sketch the resulting graph and label the axis. Okay, so here's the table that corresponds to c of x equals x cubed, and we're going to switch the x and y. So then that's -8, -1, 0, 1, 8, and -2, -1, 0, 1, 2. Okay, so -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. All right, go ahead and finish up the graph. B. Describe the transformations used to transpose the independent and dependent quantities. I reflected the graph across the line y equals x. C. Is the resulting graph a function? The resulting graph is a function. D. Compare the graphs of c of x equals x cubed to the resulting graph. Interpret both graphs in terms of the side length and volume of a cube. The graph of c of x shows that when the side length of a cube is x units or negative x units, the volume is x cubed units. The resulting graph shows that when the volume is x cubed, the side lengths of the cubes are x units and negative x units. Let's take a look at the next page. Activity 1.2, inverse of power functions. By transforming the graphs you trace the previous activity, you were able to see and sketch the inverses of the functions L of x equals x, Q of x equals x squared, and C of x equals x cubed. Okay, let's go ahead and do that again. So first off, let's graph L of x equals x. So that's -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Okay. Now let's take a look at Q of x equals x squared. So -2, 4, 1, 2, 3, 4. -1, 1, 0, 0, 1, 1, 2, 4. Okay, and let's look at C of x equals x cubed. So -2, 1, 2, 3, 4, 5, 6, 7, 8. -1, -1, 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's your power functions. Now, to do the inverses, we're going to switch the x and y values. Okay, so let's go ahead and do that. 1. Use your trace graph to verify it's inserted. All right, so let's go ahead and graph the inverse. So this would be -2, -1, 0, 1, 2, -2, -1, 0, 1, 2. It's a little hard to see the axis, so let's highlight that a little bit. Okay. So -2, -2, -1, 1, 0, 0, 1, 1, 2, 2. Okay. Again, before we do this, let's highlight the x and y axis so it's easy to see. And then this is 4, 1, 0, 1, 4, -2, -1, 0, 1, 2. So 4, 1, 2, 1, -1, 0, 0, 1, 1, 4, 2. Okay. And this is -8, -1, 0, 1, 8, -2, -1, 0, 1, 2. So then that's -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. All right, go ahead and finish up the inverses. All right, let's take a look at the next page. If the inverse of a function f is also a function, then f is an invertible function, and its inverse is written as f of -1 of x. 2. Which of the three power functions that you explored are invertible functions? Explain your reasoning. The function f, L of x equals x and c of x equals x cubed are invertible functions. The vertical line test shows that for each value of x in the inverse function, there is only one value of y. You know that the vertical line test can be used to determine whether the graph of the relation represents a function. The horizontal line test is a visual method to determine whether a function has an inverse that is also a function. To apply the horizontal line test, consider all the horizontal lines that could be drawn on a graph of the function. If any of the horizontal lines intersect the graph of the function at more than one point, then the inverse of the function is not a function. 3. If a graph passes both the horizontal line test and the vertical line test, what can you conclude about the graph? The graph represents an invertible function. If a graph passes both the horizontal line test and the vertical line test, it is a graph with an inverse that is also a function. 4. If a line passes the vertical line test but not the horizontal line test, what could you conclude about the graph? If a graph passes just the vertical line test, then it is a function, but its inverse is not a function. All right, let's take a look at the next page. Talk to talk, power lines. 1. How does the graph of a power function and the graph of its inverse demonstrate symmetry? The graph of a power function and the graph of its inverse are symmetric about the line y equals x. The line y equals x is a line of reflection or a line of symmetry. Go ahead and mark these out. They, for whatever reason, decided to put the power functions on this page, so you're welcome to look over them. All right, you can mark this out. The student works 1A, 1B, 1C, 2A, 2B, and 2C. And then you can mark out this. All right, you can mark this out. The student works 1, 2, 3, and 4. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.